Good afternoon, good morning, good evening, wherever you happen to be. This is session 8F. Please remember to give feedback at the end. This session will be given by Tim Brooks, and it's about proactive incident management with AI and machine learning for anomaly analytics. Tim, over to you.
Great. Thank you so much, Anna, for the introduction. I'm here streaming from Raleigh, North Carolina. And I'd just like to thank you ahead of time for your time here. We're going to cover quite a bit of content today. And I really want to start at a high level of why people are investing in anomaly analytics. What is the point of anomaly detection? What are the different types of anomaly detection we can do? And why it's important to look at keeping mainframe insights as a first-class citizen in the hybrid multi-cloud landscape and giving you that full mobile to mainframe observability. At the end of this presentation, I'll also give you some pointers to additional information if you want to learn more. And as always, please feel free to reach out to myself or my team. We're happy to engage and talk more about this topic. And please, if you do have questions throughout this presentation, please do feel free to enter them in the chat and we can address them in real time. So let's talk about some of the market challenges and why people are investing in anomaly detection. Some of the main challenges that are driving the need for machine learning and artificial intelligence is the velocity of change and the increasing workloads that are becoming more unpredictable on the mainframe. With hybrid cloud integrations, right, we're starting to actually see an increase in transactions, which again is driving more workload on the platform. So ensuring that you have that 24/7 availability and resiliency is paramount for your enterprises and businesses. And with that hybrid cloud landscape comes an explosion in data. Now, every single node within a hybrid application is starting to generate data and noise, and it's really hard to manually sift through all that data. So we need to figure out how we can analyze it automatically and derive insights. And lastly, we have IT operations skills, right? Teams are being asked to do more with less. So again, how can we leverage machine learning to help those teams get advanced notice of potentially SLA impacting events so that they have more time to, identify, isolate, and remediate the problem before it becomes an SLA impacting event. So anomaly detection is really a solution that's geared to give you more proactive incident detection. So that's where, on this workflow here, we've highlighted this is really the scope of what we are trying to address with anomaly analytics. So let's talk a little bit about what it is and how anomaly detection can actually provide you with more proactive advanced warning. So let's talk about what people are doing today. Monitoring solutions have been, in the market, been part of enterprises since the advent of, the mainframe, right? And a lot of times when you have these traditional monitoring solutions, you set what are called static thresholds. And this is the point in the conversation where I would have people raise their hands and tell me, how do you set these static thresholds? And as I've engaged with customers, the response that they give is, well, I had a problem, I analyzed the problem, and then I noticed that, if my static threshold exceeds this limit, then I know I'm going to have an issue. And so it's really about domain knowledge and experience that people have started to set these thresholds. And this is really good, right? If you know a certain threshold, it's valuable, right? But that doesn't scale, right? It still requires individuals to analyze problems for an event to have already occurred so that you can, monitor it and make sure it doesn't happen again. And so what we're seeing is that it's not until your real-time metric starts to exceed that static threshold that you would be alerted to a potential problem. Now, with machine learning, we're starting to put the work on the machine to identify what those thresholds should be using historical data. So rather than requiring domain knowledge or experience from, someone else, we can start to slice and dice the data and get a lot more granular. So one of the great things about machine learning is that using that historical data, we can actually identify what normal operations looks like from your historical data. And we can say a Monday at 8 a.m. looks different than a Monday at 9 a.m., 10 a.m., 11 a.m., right? Based off of your historical data, we expect to see these thresholds be at different levels throughout the day. We can also differentiate between a Monday and a Tuesday, a weekend versus a weekday, and it allows us to be a lot more, precise and a lot more granular in how we monitor these trending items. So each one of these boxes you can think of as a boundary or a threshold for each given time increment of the day. And the other great thing about machine learning and artificial intelligence is that we can layer on different types of logic. So for example, in the static threshold with traditional monitoring solutions, when your real-time metrics exceed that static threshold, they generate an alert. However, in machine learning, I can say, okay, well, you exceeded the threshold, but is it still going in the wrong direction, right? Is it getting worse? Is it trending in the right, or starting to trend outside of bounds even more? And it's at a certain point of statistical significance that I can then choose to alert your IT operators or your ZSMEs about this potential issue. And because I'm looking at smaller symptoms growing over time, I can alert them when I get to a statistical significance that it's highly anomalous and it's at T0 that I can actually generate an alert and tell someone, hey, you've got some abnormal activity here. You really should check this out before it becomes an SLA impacting event. So this is where the power of machine learning and anomaly detection allows you not only to scale to address a wide variety of use cases where perhaps you don't have historical knowledge, so we can start to identify your unknown problems, versus with traditional monitoring, it's really about your known knowns. So this really helps you to reduce your dependency on historical domain knowledge or tribal knowledge when setting and managing thresholds. So then the question becomes, well, how proactive is proactive? How much advance notice do I get? And like any engineer, the answer is always, it depends, right? But what I want to show you now is the logic behind how we think this can really help with proactivity. So at the top here, let's talk about, again, let's go back to your traditional monitoring solutions, right? When problems emerge, there's usually smaller problems that start to show up, that start to grow. The symptoms continue to grow and grow and grow. And it's not until, again, you breach that threshold or you get a phone call that end users are experiencing, something bad or a failure. It's only at that point that you're alerted to the problem, and then it's at that point that you actually start your diagnosis time. Once you diagnose the problem, then there's the resolution time. So it's really not until T4, time frame number 4, that you actually start to do the work, because you haven't been alerted to the problem until it's grown to a significant, situation. But with anomaly detection, right, I'm starting to detect these symptoms. I can start to see that this is abnormal activity. And rather than waiting until a significant failure, I can alert you when I have statistical significance saying this is very abnormal. You really should be checking this out. And because I've started to address the problem before it became an SL impacting event, ideally, I have a shorter diagnosis time, especially because I'm pointing you to the exact anomalous activity that you're monitoring. And because you have a shorter diagnosis time, ideally you have a shorter time to recover, ultimately enabling you to have better SLA agreements. So with that, I want to introduce you to a solution that can kind of dive into more about what anomaly detection is, how it's done, and some of the insights that you can derive from a solution like IBM Anomaly Analytics. And when I describe this product, I usually like to focus on what I consider to be four key features within the solution. The first one is around environment modeling, right? Using machine learning, I can help you understand what normal operations looks like for your subsystems, as well as for your metrics and logs. And once you have a baseline model of what normal operations looks like, we can actually perform two different types of anomaly detection. The first type is metric-based anomaly detection. And in the solution, we can actually detect anomalous activity for DB2, KICS, MQ, IMS, and ZOS. And we've developed what we call key performance indicators, or KPIs, that are particular time series metrics that we've worked on with our data science team to say, if you're monitoring these specific KPIs, this will help you evaluate the overall health of that system. The second piece of anomaly detection that we provide is what we call message-based anomaly detection. So by looking at the metrics, you can start to understand impact to performance. And when looking at messages, you can start to see, abnormal or weird actions that the system has taken by looking at your syslog or your oper log data. And because messages are unstructured, we actually have a completely different algorithm that starts to look at the occurrence of those messages, how frequently those messages are cut, what are the sequence of the messages, right? If you expect to have message A, and that's abnormal, and you really, after message A, typically you see message B, but message B never occurs, that's an anomaly. That might be an indicator to something or something going wrong or a problem that needs to be addressed. So by bringing together both messages telling you the abnormal actions that the system took, aligned with the metrics talking about the performance and the impact to performance, you can start to get a holistic view of an emerging problem. And that brings me to our fourth feature, which is what we call our topology service. So in addition to monitoring metrics and logs, you also want to understand the relationships, the context, how impactful is this anomaly? And what we provide is a solution that looks at your deployment configuration dependencies. What are the relationships between ZOS and DB2 and DB2 and KICS and IMS and MQ, right? What are the relationships across all of those different subsystems? Because it's really important to understand how things interact with each other and depend on each other when you want to assess the potential impact. So that's what we have as our topology service. And ultimately, right, we don't want to have your IT operations teams sitting in front of a dashboard. We want this to be an event-based solution. We want your teams doing higher value work and only being notified and brought into the solution when anomalous activity is actually detected. So what we do is we generate alerts and events that can be configured to be sent anywhere. EIFs, webhooks, APIs, right? We want to be able to notify your IT operations teams using those events. Those events can also be sent to your event management systems, or if you are investing in hybrid cloud, right? We can also send those to solutions like the Cloud Pak for AIOps, which is an application-centric AIOps platform that can then correlate the insights across your distributed environment with that of Z. So again, understanding how Z impacts your hybrid multi-cloud landscape. So what I'd like to do is to dive into this into a little bit more detail. And so let's dive into the metric-based anomaly detection feature. One of the most recent items that we've released is a new architecture for our metric-based anomaly detection solution. We've invested a lot into making this solution leaner and meaner. We've removed dependencies, we've containerized the solution, and ultimately accelerated deployment time to help you get up and running. And like I mentioned before, we support anomaly detection for ZOS, DB2, KICS, MQ, and IMS. And we now provide key performance indicators for all of those subsystems. We have about somewhere between 60 to 80 KPIs per subsystem. And this solution does not require you to have AI and ML expertise or to have data scientists that you need to help you select those KPIs. We actually provide you with what we call pre-built KPI models, meaning that all you need to do to get insights out of the solution is train the model that we deliver to you using your historical data. And so on day one, when you have this solution installed, configured, and trained, you can start to generate AI insights. And we also have invested in making it so that you don't have to be an expert to understand what these AI insights mean. We delivered a new functionality which we're calling KPI context. So within the product itself, we've embedded our IBM ZOS domain knowledge to help you analyze what it means for a particular KPI to be anomalous. And almost, as important of that is we're doing near real-time scoring. So as your SMF records are being cut, we're analyzing them in real time. So that will help you, evaluate what normal operations looks like, how your real-time metrics compare to those normal benchmarks, and get those insights in real time. And as I mentioned before, I don't want you staring in front of this screen. I want you doing better, higher value work. So when anomalies are detected, we can generate an alert that can be used to alert your operations team. So let me just focus on a little bit of our metric-based machine learning architecture. Now, traditionally, we had dependencies on ZOS for our metric-based machine learning feature. We've actually removed the dependencies on DB2 and MLZ. They are great products on their own, but when using them to create our full anomaly detection solution, it ended up causing, complexity and configuration steps for deployment and configuration. And so the feedback we got from our end users was, make deployment easier. And so this is exactly what we did. And in making it easier, we actually made it more performant. We've increased the training time. We've increased the decreased the amount of CPU it takes to do inferencing. And we can now handle 7.5x the volume of real-time training and inferencing. So with our new solution, it is a fully containerized solution. It's got an internal data warehouse, and it's got a Java-based analytics engine that can just be leaner and meaner. And if you're looking at finding out more information about these performance metrics and these enhancements, we have a blog here, which I provided a URL in the charts. So if you want to download the charts, you can also get access to that blog. So this is really important, right? Because as we start to consume more data, we need to make sure that it's cost effective for our customers to perform anomaly detection on a broader, more wide variety of KPIs than what is currently, supported today. So continued investment. This is a huge milestone that is going to unlock us the ability and capacity to do even more AI ops use cases. So really excited about this release. So let me talk a little bit about the data flow, right? How do we actually perform anomaly detection? So the first piece of, insights is we can leverage your historical data. So you can actually use a solution called IBM Z Common Data Provider, which is able to batch load your SMF metric data into our data warehouse. And from there, we can then build a model of what normal operations looks like based off that historical data and create that model. Once we have that model, we use the same component, IBM Z Common Data Provider, to then stream those metrics in near real time and then compare those metrics against the model to identify anomalous activity. Also, once we identify anomalies, alerts can be sent, and those alerts include an embedded URL that takes you back to the product so that you can understand from the UI the impact and the insights from that solution. So let's talk a little bit about what it would look like. So in this example, imagine you have a Kix region, and up at the top right, it actually will tell you the sysplex name, the system name, and the Kix region's name. It also summarizes that we found 16 KPIs across 4 different KPI groups that have abnormal anomalies that should be investigated. Up at the top right here, you have a couple of different navigation features. You can look at different time ranges. You also have some filtering capabilities that you can, say, only show me the anomalies that are low or high. Don't show me any of the normal. And below is what we call our scorecard. So each of these boxes represents a time range. In this instance, right, each box represents 30 minutes, but you can get more granular. You can get down to the 10-minute interval. You can, zoom out to get to the hourly interval. So you have that ability to zoom in, zoom out using this time range feature here. But essentially, on the left-hand side here, we have our KPI groups. So we have a number of individual key performance indicators that all relate to storage, that all relate to different tasks on Kix. And there's a number of other different KPI groups as well that aren't shown on the screen. But if you were to expand tasks, you could see CPU time and you could see transaction count. And if you were to expand any one of these lines here, you would then get to see your chart. Now, there's a lot of information that's actually displayed in this chart. The first is, let's look at the different shades of blue. Up here, you can kind of see, the key for what they mean, but anything that's in this lightest shade of blue represents what we would expect for normal operations. Based off of your historical data, based off the model that we built, if your real-time metrics, which is denoted by the solid black line, is within the lightest blue shade, that means you're within normal operations. If your real-time metrics start to go into the medium shade of blue, this is where, okay, we're going to start doing some trend analysis. You're slightly deviating from what we believe to be normal operations. So I'm going to start doing some additional logic on this. I'm trying to figure out, is this a problem? Is this something I should alert your IT operator to? And if the real-time metric exceeds the medium threshold and goes into the darkest shade of blue, that's considered a high anomalous activity. That's when we are going to generate an alert. And so you can see on this chart here that the numbers in these boxes represent your anomalous activity score. So a score of 0 is very good. A score of 60 means you're starting to get into that low anomalous level. And a score of 90 or above means it's highly anomalous. I'm going to send you an alert at this time. And so very quickly across the 60 to 80 so different KPIs, you can start to understand and put together the pieces of the story or the timeline of anomalous activity as it's occurring. Also, when you hover over the graph, you get additional information, such as what the actual value of that metric is. So, for example, transaction count, you can see you've got 21,359 transactions, but this is actually in the high anomaly range, where if you exceed 19,000 transactions, then during this period of the day at 8 p.m., if you exceed that number, then that's a high anomaly. But if you're below that, then you're in a low or normal anomaly level. You can then also see the previous last 4 deviation scores. So even if you're looking at this 30-minute time window, you can see that at 8:20 p.m., it had an anomaly score of 91. 8:10, it was 91. 8 o'clock, it was 90. But at 7:50, right, it was at 74. So it was between 7:50 and 8 p.m. that you jumped from low anomaly to high anomaly. Again, helping you determine the time period in which this problem occurred. Now, as I mentioned, we want to help you understand and interpret these results. So we've added what we call KPI context to the solution. So each of the 400 KPIs that we support in our product today, if you click on the little information icon next to the KPI description, we tell you what the KPI is with a plain English description. We actually tell you how this KPI was calculated, what SMF records it came from, what field names we're looking at, giving you that transparency, that trust that you can, really understand what these insights are. And we provide you with an explanation of what it means for this KPI to actually be anomalous, helping you guide you towards a potential action that you can take to remediate the problem. So again, trying to provide you with guidance and evidence on how to interpret and your potential next steps you can take. So that is what we do with metric-based anomaly detection. Now I want to move to the second feature, which is log-based anomaly detection. So in this case, we're using a completely different algorithm. It's a completely different data source. We're talking about unstructured data. We're looking at your ZOS messages, your syslogs, your oper logs. And instead of looking at trending time series data to do, build a model of what normal operations looks like, we're building a baseline using your historical message data. So again, we're looking at the frequency in which messages are cut. The clustering, right? Do we expect to see messages come in a group, or are they one-off type of independent messages? We also have domain knowledge in there that can help us determine whether or not it's informational, whether it's an error message, whether this is something that is, a high severity message or a low severity message. We can start to build in that IBM-Z domain knowledge into the solution, into the algorithms. And so once we build a model of what normal operations looks like for your messages, we do this, very similar type of anomaly detection. But instead, we're looking at, atypical frequency of these messages, the sequences of these messages. We even now have delivered the ability to dig into an individual message and find a variable within that message that has gone highly anomalous. This is helping you find that needle in a haystack to help you describe what actions the system took and what that impact could be to the environment by marrying that up with the metric-based anomaly detection. And again, I don't want you to have to sift through all these messages. I'm going to generate an alert that points you to a time range and a particular message that you should really investigate. So again, trying to be more proactive with these potential incidents. So let's talk again about how do we actually do this? Again, this is actually very, very similar to metric-based machine learning. We use a lot of the same componentry. We are able to use IBM-Z's common data provider to, again, batch load your historical messages into an internal database. And from that database, we are able to use our machine learning algorithms to build a model of what normal operations looks like for your messages. And similarly, just like metrics, once you have that model, the process is very similar, right? We're then going to stream those messages in near real time and compare that message to the model. And we're going to then generate anomalous anomaly scores. And when those scores exceed a certain, threshold as dictated by the model, we'll generate an alert. And that alert will include an embedded URL that takes you back to the product UI. And again, this will help you to, really diagnose the issue by drilling down into those logs. So what does it look like? Now, the only thing that really brings together metrics and logs is timeline, right? Time is so important when it comes to problem and incident detection. And in this view, right, similar to the other previous scorecard view, you have the ability to see, what sysplex it is, what your dates and your time ranges are. And each box in this view represents a 1 hour time interval. We call it a 24-hour peak. Think of this as like a high water mark. And when you hover over one of these charts, one of these timeline intervals, you can actually see the anomaly score. And you can see the number of messages that reported as anomalous activity. And by clicking on the particular time frame in which the anomaly score was significant and high, it brings you to this view. This view, again, is going to give you a lot of information, right? Up at the top left, this gives you your context, right? What system was it analyzing? What was the date? What was the time at which this anomaly was detected? There were 66 unique message IDs that had a total anomaly score of 101. And below, we actually surface to you the individual messages that contributed to this high anomaly score. So overall, at the bottom here, you can see that there were 66 total messages cut. We have, just kind of made this a little bit more manageable. You can scroll across the table to see all 66 of those messages, but here are the ones that are most highly anomalous. So up at the top here, you read it going across. You can see a very high anomaly score. This interval contribution score says, out of this overall 10-minute time interval between 4 a.m. to 10 a.m., how much did this particular message contribute to the overall score? And so in this case, you can see that all 4 of these messages contributed equally, but that is not always the case. There's also the clustering status, right? Do we expect this to be part of a group of messages? Do we expect them to be individual messages? Are they messages that have been new and never before seen before in your training data, right? So this clustering status helps you understand, have I seen these messages before, and what is the pattern in which I expected to see these messages? The count column tells you how much that individual message, how many times that occurred within that time interval. So this first message occurred 24 times within that 10-minute time interval. And this time interval is depicted by this bar, these bars over here. Every green line represents one of the 24 times that that message was cut. And so by providing this timeline view, you can start to understand the sequence in which these messages occurred. And as I mentioned before, we've embedded, again, more logic into this solution. Working with our ZOS team and our data science teams, we have internal rules that can start to label messages as important, unimportant, non-interesting, informational, right? And so we've done the data science work for you to understand which messages you should really be looking out for. And on that point, we actually provide you with the message right in the UI. You don't have to do any searching for it. It's right there, and you can start to see the message ID and the individual message itself. Now, you might be saying, okay, great. I found a very anomalous event, but has this occurred in the past? When did I first see this message? If you actually click on the message, right? So here we're searching for message ASN 0522I, right? And you can see which system those messages have been detected on, when those messages were actually detected, how many times they occurred. Again, the summary text status, the anomaly score, the clustering status, the periodicity of it, right? So one thing you can see as well, actually, the first time I ever saw this highly anomalous message was between 5 and 5:10 a.m. Not within the time frame of when I kind of expected it to be, or when it became a really significant problem. So again, you can start to drill down into more details about individual messages. If you found a message that you already wanted to investigate and see if it went anomalous, you can also search for those individual messages as well. So again, what we are trying to do with this solution is to help accelerate your problem isolation, accelerate the time you have to actually investigate it by giving you more proactive detection and alerting of the problem using anomaly detection. So let me talk about one of the final features of the solution, and that's our topology service. So when you detect an anomalies, you might say, okay, so what, right? I know from the performance data, I know kind of the severity, right? of the issue because I can see how far outside of the bound a particular metric is. With my logs, I can understand what were some weird actions that the system took that maybe led to that performance impact. And now with the topology service, I can say, well, how impactful is this to the rest of my environment, right? What's my impact analysis? And by gathering information about your deployment configuration dependencies, I can now start to map out the relationships of those dependencies. So for example, I can see that this ZOS system G has a, requirement on Kix, and Kix makes a call to this particular DB2 subsystem. And I can now overlay on top of this topology the anomaly status. So red indicates that you have a high anomaly on this particular node within your topology. Green means you're running normally. I can now quickly assess, okay, it's the Kix region that is having a problem. Downstream to DB2 appears to be running normally. And I see this relationship with this other Kix region, and this Kix region is doing fine. There must be something more granular happening in Kix WA1. Let me go investigate. You can actually click on the node and open up your metric-based scorecard view and start to quickly understand you've got storage anomalies, task anomalies, dispatcher communication anomalies, all happening at a similar time. And so then you can, again, just like you navigated the same interactions you had previously, right? Expanding these to understand the individual KPIs that are leading to this anomaly score for this time period, you can start to really drill down into your investigation. Now, this topology service is really, really valuable. Without understanding the relationships of how your ZOS environment relates to one another, you can't start to take a hybrid approach. You really need to get your Z observability in order for you to then provide that information to now perform hybrid observability. So this technology, this topology can be sent to another AIOps solution. It can be exported out of the product and ingested by another solution, such as the Cloud Pak for AIOps, to do hybrid cloud incident detection. And in addition to the topology, all the events for both metrics and logs can also be sent there so that your Z insights can be correlated with your, cloud or your hybrid insights. Again, focus on making Z a first-class participant in your hybrid multi-cloud landscape. And so this is what it looks like, right? The Cloud Pak for AIOps is a cloud native application. It's got a lot of cross data source correlation algorithms, and Cloud Pak for AIOps is really focused on evaluating the health of your overall hybrid application. So out of the box, it's monitoring your distributed platforms. It's looking at your structured data, your events, alerts, metrics, topologies. It's looking at its unstructured data, such as logs and incident tickets. And now from the Z side, right, we are focused on really evaluating the health of the System Z environment. But those insights, we can summarize them. We can put them in context and share that information with the Cloud Pak for AIOps that then does the correlation across these different domains. So we're really breaking down our own silos of, hybrid cloud incident management to help our customers also achieve greater resiliency. So I want to kind of pause here and see if we have any questions so far.
There's nothing that's occurred in the chat.
Okay.
I
All
could
right.
unmute if anybody wants to ask a question, but they can ask in the chat for that too.
Okay. Well, so let me kind of end by talking about some additional next steps that you can take and some additional resources. So, first of all, we have a lot of information online as it relates to the ability to read about our product announcement. You can go to our product page to find additional information about some of the features that I've presented to you today. And we have our Z AIOps community. It's an online community. You will find blogs, you will find demo videos. You can actually engage with myself through the community chat function. And so if you want to reach out to us, that's another great resource that you have to learn about the solutions and this AI ML domain space. And also, it's often really hard to evaluate how valuable this solution is in your particular environment. So one thing that I would encourage you to do is don't take my word for it, right? Test this out for yourself. Validate and make yourself confident in using AI and ML. And to do that, we provide what we call remote proof of concepts. So you can, take a historical problem that you had in the past, provide that data to IBM, and on IBM infrastructure, we'll run that data through the solution and read back to you and demo to you what the insights were from that product. That can really help you accelerate your evaluation of if AI and ML is something that you want to invest in. You have no need to go through install or manage your own environment. And again, you can evaluate the product using your own data. And so if this is something that you're really interested in, again, you can reach out to myself or Lee Wang, who is our leader in delivering these proof of concepts. And as I mentioned before, I'm really, really excited about our new architecture. It's more performant, it's leaner and meaner. This is opening up the aperture for us to do a lot more interesting AIOps use cases. And so we would love to be able to talk with you, make sure that our roadmap is really aligned towards addressing your most critical business needs. And so we really do enjoy the co-creation process. And so if this is an area that you're interested in, again, you can reach out to myself or my design leads here. And one of the benefits of participating in this is that you get previews into our upcoming releases, our new features, and you influence our roadmap. If you don't see something or you want a use case that's supported, but you don't see it in the product today, talk to us about it, right? You get to influence our roadmap. We work for you. So that's another shout out as another way that you can get engaged. And again, I'll just end here. Join us in our community. Lots of great content, blogs, videos, red papers, events that will be coming up that, again, you can really connect with our leaders in AIOps and machine learning. So with that, I'd like to thank you for your time here today. Please let me know if you found this session interesting. Please leave your review. And I will close with thanking you again for your time. And I'll stick around to see if there are any other questions or if anybody else wants to come off mute.
Okay, so I have set the system so that you can unmute yourself should you wish to talk to Tim about anything in general or about the session. Please provide feedback. And the slides have been uploaded, or they have?
They have,
okay.
yes.
Excellent. So if you thought, oh my goodness, I didn't get a picture of that QR code, not to worry. You can find it on the slide deck, which you can download from the agenda.
Great. Well, if there are no questions, again, thank you for your time and appreciate your feedback.
Okay. Thank you, Tim.
All right. Thank you, Anna.
Cheers.